Okay, so the next thing we're looking at in college algebra is converting between radians and degrees. So that's our topic for today. And the essential question is, how do we convert between them? So how do we go from radians to degrees, and how do we go from degrees to radians? And kind of before we start it, I just want to think for a second about converting a little simpler thing. So let's say we looked at just on the side here, like we were going from feet to inches, or inches to feet. I guess it could go either way. So if I had, let's say we had 4 feet, how would you change it to inches? Well, you know that in each foot, so 1 foot, there's 12 inches, kind of like we do in science when you convert units as well. The feet would cancel, you'd multiply straight across, and you get 48 inches. Okay, so that's how you convert from feet to inches. It's really the same thing when we're looking at radians and degrees. So it's kind of that same idea. There's conversion factors that can change them. So we're going to look at conversions today. It should be pretty straightforward compared to a lot of things we've done and what we'll be doing next. So the first one we'll look at is degrees to radians. So I'm just going to abbreviate that as D to R, and then radians to degrees. We'll show you both directions. So the first one, if I'm starting with degrees, I'm starting with some angle to some degrees. You are going to multiply it by a conversion factor. Just like we did here, we knew there were 12 inches in a foot. Okay, so any conversion factor you have, you can use that. And we're using that because the feet here will cancel the feet on top. Okay, so if I'm looking at this, I know this is degrees, which means I have to have degrees in the bottom. And I'm trying to go to radians, which means radians has to be on top. And the easiest one to do is we know that 180 degrees is the same thing as pi radians. And when you do that, when you multiply, the degrees on top is going to cancel with the degrees on the bottom, and your answer will be in terms of radians. Okay, same thing kind of happens when you're looking at, I'll kind of box that here, this is your formula you're going to use. When you're looking from radians to degrees, you have X number of radians, whatever the number is, whatever the fraction is. You multiply it by, radians has to be the denominator to get them to cancel. So the easiest conversion again is pi is the same thing as 180. So 180 is degrees, and pi is radians. Again, the radians would cancel, and you'd be left with degrees. Okay, so those are the 2 different conversion factors we're going to use. Okay, so as long as you have the 2 conversion factors, it should be pretty straightforward. So let's look at, let's go for the first example. We'll go from degrees to radians. Okay, so let's say I have 135 degrees. And let's say B is 540 degrees. And let's say C is 190 degrees. So we're going to do 3 different ones. So I'm starting with degrees and I'm going to radians. So all you do is take 135 degrees. You multiply it by the conversion factor. So we're starting with degrees. So I'm going to look at this one here. Okay, because I'm starting with degrees going to radians. So I multiply by pi radians over 180. So the degrees again would cancel, and you multiply straight across. 135 is just over 1, so when you multiply straight across, 1 times 180 is just 180. And the bottom is 180. And on top is 135 pi. You could divide that 135 by 180, simplify this fraction down. You can do the calculator by hand either way. And you end up with 3 pi over 4. So 3 pi over 4 is the exact same thing as 135 degrees. So let's just stand in at 540. So take 540, multiply by pi over 180, because again, it's the same ratio every time. The degrees will cancel. You're left with 540 pi. Again, multiplying straight across here over 180. And that goes down perfectly. 540 divides by 180 just to get 3. So you're left with 3 pi, and the bottom would be 1. But you don't need to write that. So 3 pi is the same thing as 540. Okay, go ahead and try C here. I'll pause the video and then I'll show you the answer. So give it a shot, and then I'll show you the answer here in about 5 seconds. Okay, you should be able to see my answer now. I multiplied by pi over 180 again because I'm getting rid of the degrees. And then you get 190 pi over 180, which can simplify down to 19 pi over 18. So hopefully you got that answer. Okay, so example 2 now, we're going to go the other direction. We're going to go now from radians to degrees. It's really the same kind of idea, just reversing it. So I'm going to do 3 different problems again. So let's say I have, I'm going to go with negative pi over 2. We're going to go with 9 pi over 2. And let's go with just the number 2. So this one has no pi's in that one, just the number 2. So again, all you're doing is multiplying it by the conversion factor. So this would be negative pi over 2 multiplied by the conversion factor of, so this would be radians on top, so it means radians is being the bottom, so it would be pi over 180. Again, we're looking back at this conversion factor right here. The radians will cancel, so the x right here in this particular problem is negative pi over 2, and then 180 over pi. Okay, and the cool thing about radians often, if you have pi's involved, is they will cancel. So if you look at this pi on top is going to cancel with this pi on the bottom. Or you get 180 pi over 2 pi, and the pi's cancel at that point. Either way you want to think about it. But the pi's cancel, and you're left with negative 180 over 2, which negative 180 divided by 2 is negative 90 degrees. Which you should recognize, pi over 2 is the same thing as 90, so negative pi over 2 is the same thing as negative 90. So we do the next one, 9 pi over 2, multiply by 180 over pi again, the conversion factor. Again, the pi's will cancel, and you end up with, what's it, 1,000. I'm going to write it out this time, so instead of crossing the pi's out, I'm going to leave it in there. So it's 1,620 pi, because I multiplied straight across, over 2 pi. If you want to cancel the pi's out now, that's fine as well. So you just divide that, and I get 810 degrees. So that goes around more than once, more than twice actually. So that would be the same thing as 9 pi over 2. Okay, go ahead and try the last one. It's a little bit different just because there's no pi's involved, so pi's will not cancel out. But you still do the same process. Still multiply by the same conversion factor. Your answer is just going to be a decimal in this one. So give it a shot. I'll give you 5 seconds again, and then I'll show you the answer. Okay, here's what I got for C. You have 2, which is just 2 over 1. If that helps you. And then you multiply. When you multiply straight across, straight across. In this case, the pi's do not cancel, so you get 360 over pi. You divide that answer, and you not quite get a whole number, but that's okay. It's about 114.6 degrees. Okay, so that's pretty much all the work for today will be that. One other thing I do want to show you that will come up in the future, I don't think it's on any of the homework assignments for today, but it will come up in the future, is converting to decimal measurements. So we'll look at this real fast. You might have seen this before, but maybe not. We won't see it that often in trig, but slightly. So convert to decimal measure. So occasionally the textbook or problems will, instead of giving you like this, 114.6 degrees, they'll do it in terms of what they call minutes and seconds. So they do like 54 degrees, 46, they put a 1 dash, and like 24, and then 2 dashes. Okay, it's kind of strange. This one is called minutes, and this is called seconds. So it's 54 degrees, 46 minutes, and 24 seconds, which is weird. And I don't know why they did that. Maybe someone could look it up and tell me why. But how you break it down in terms of decimal is this is a whole 54. So that's just days is 54. Think of it in terms of minutes. So minutes, instead of a normal number where it's out of like 100, minutes is out of 60. So you're actually having 46, but it's minutes, which is actually 1/60th of a full thing. Plus 24, and seconds, if you're talking about, so this is minutes, this would be hours here at the end kind of idea. So it's 1/60th every hour. Seconds, there'd be 1/3600. So 24 seconds would be that many hours at the end, so that's the total amount. And then you just basically multiply those out and add together, and you end up in this case with about 54.77. Okay, I don't believe that happens on any of today's work, but it might happen at times when you're going to end up with something where they write it out in minutes and seconds, and you have to convert it into decimal form. If that happens, I'll try to give you an example later on so we can talk about it. Your work for today is all conversion stuff. Again, I'll give you the page on Google Classroom, but its number is 55. That's a bad 5, but 55 through 70 on page 139. And all you're doing is converting from, the first ones are converting from degrees to radians, and the next ones are converting from radians to degrees. Okay, if you have questions, let me know. This is due again on Wednesday, I believe? Wednesday at 10 p.m. Okay, and then Wednesday will be a work day. So on Wednesday, you can work on the homework like this one. If you didn't do Monday's homework, you can do that. You can also start the MyOpen Math assignment. At this point, you should be able to do all of those questions. That's due on Friday, but I will get it done today, so you don't have to worry about it on Friday, because Friday will be your other work day. Again, if you have questions, please let me know.